Hello everyone, welcome to my U Programming Club. Today we will be solving another daily Leetcode challenge, and the challenge name is number of flowers in full bloom. So you are given a zero index 2D integer array flowers where uh, flowers ith entry in the flowers array will represent the starting and the ending point of uh, the time that will flower be the time at which the flower will be in full bloom. So the flower will start to full bloom in from start I time, and it will end at end I time. Okay. You are also given a zero indexed array of peoples of size n, where each entry in the people's array will represent the time that uh, each of those persons will be visiting to see the flowers. You have to return an integer array answer of size n, similar to the equal to the size of the people's array, where each entry in the answers array is the number of flowers that a person at say at ith index will be able to see, which will be in full bloom. Okay, so the problem statement is something like this. There are some flowers. You are given the start time and end time combinations of full bloom of each flower, and there is a there are n persons, each visiting from 0 to n minus 1th, each having a index from 0 to n minus 1, and their visit times are given to you. Let's say the 0th person visits at 2 unit of time, and the n minus 1th person arrives at 5 unit of time. Okay, so this way the times at which they will be arriving is given to you, and you have to tell, let's say, for this n minus 1th person, or say the nth person, how many flowers are at full bloom when this person visited. And you have to do this for every person. Okay, so a brute force way to solve this particular problem will be, let's discuss the brute force approach first. You have to do a single traversal of the people's array. This will be for the people's array. This is necessary to uh, form your answer array. So, and let's have a look at the constraints before moving to the solution of the brute force. So the constraints are that the flower's length will be of uh, order 5 into 10 raised to power 4. So the flower's length will be of order 5 into 10 raised to power 4. Okay, and similarly people's length will also be the same. Okay, so then what you will do is, you will find all the flowers which have started to bloom before which have started to bloom before or after, not after actually, it will be before or at the time of person's arrival, and let's call this number as bloom start. Bloom start number. Okay. And similarly, we will find, let me erase this part. Similarly, we will find bloom end number. Okay. So these will be the number of flowers which have started to or not started to, it will be ended, which have ended to full bloom. Here also it will be full bloom before or at the time of person's arrival. Okay. So these two values I need to find out, and your number of flowers that will be in full bloom will be number of flowers in full bloom. What was the name of the entity? Full bloom start number and full bloom end number. It will be nothing but full bloom start number minus full bloom end number plus 1. It will be something like this. If you consider a number line, then this will be your full bloom start number, and this will be your full bloom end number. You have to tell the number of flowers including these two. So it will be nothing but actually this quantity will be greater than this, so we should reverse their positions. because starting point will always be lesser than or equal to ending point. And let's cross check in the constraints also. As you can see, starting point is always lesser than or equal to ending point. So it is well understood that number of starting points will be more than the number of ending points. Okay, so it will be the bigger quantity, which is full bloom start number, minus the smaller quantity plus 1. Okay, plus 1 will be done to accommodate this quantity also in the count. Okay, this will be the number of flowers in full bloom when, let's say, the ith person visits. So what we will do here is we will run a loop and find these numbers. But let's say if we run a loop on, which will be the array that we will be running loop on, flowers array. Okay, let's say both of these are taking linear times. So the linear time complexities will be order of n. N here is 5 into 10 raised to power 4. Similarly, 5 into 10 raised to power 4, since there will be two loops. Okay, and it will be 25 into 10 raised to power 8 operations. So these number of operations are more than the limit of 10 raised to power 8 operations. Basically what happens is, if the number of operations of your program or let's say the number of operation your program is needing to solve the particular problem is greater than or equal to 10 raised to power 8 operations, then you may get a TLE. Operation limit. This is the operation limit. In this case, you will get a TLE. Time limit exceeded. Your solution will not be accepted. So in order to get your solution accepted after submission, you have to optimize this approach. So where when we can do optimizations? For this particular part, we cannot do any optimization since this will be required to form the answers array. Not possible. In this particular part, we can have optimization. What will be the optimization? I will tell you. So let's say we separated the start and the end points. Okay. Start points of flower boom, flowerful boom, and end point of flowerful boom. Okay, let's say we separated them. And what we will do is we will sort them in ascending order. Here also we will sort them. Ascending or descending, it depends upon your choice, but they need to be sorted. Okay, then what we will do is we will apply binary search. Since they are sorted, binary search can be applied for the start point to find what? To find all the flowers which have started full bloom before or at the time of person's arrival. Okay. And similarly, we can binary search for the number of bloom and number in endpoints. It will be done in endpoints. It will be done in start points. The number of flowers which have ended to full bloom before or at the time of person's arrival. Okay, these two you will calculate, and yeah, that's pretty much it. And at last you will calculate this number of full blooms, which will be nothing but full bloom start number minus full bloom end number plus 1. Okay, now without further delay, let's try to implement this solution. There you will be able to understand it in a much clearer way. I think this zoom level will be fine. Let's start. So size will be holding the number of people that we will be visiting. So people dot size. Okay, then we will do a single traversal. Okay, this is how you will be forming your answers array, and let's declare your answers array. Vector in case of C++. Okay, and if not if uh, you will find the number of you will find the start number, what the variable name was, bloom start number. Just a second. Yeah, we can continue now. We will find bloom start number, which will be we will make a function find bloom start number. It will be flowers, people. Let's declare a variable to store the arrival time of the ith person. It will be people dot size. Oh, not people dot size. Pardon, please. It will be people ith index. Or okay, and we will pass arrival time. and then we will calculate bloom end number. It will be find another function will be declared find bloom, or we can use the same function since we are requiring a similar kind of values only. So what should we name this for a more generic find bloom number? It will be more suitable. Similarly, same function will be called find bloom number. Basically, here we will separate the start and the end times. So we will say start time, bloom start time. Okay, here we will pass. So the arrays that on which we are doing binary search is are changing here bloom end time. Okay, uh, and we forgot to separate the start and end the ending times. So let's do that. What we will do is for the times starting and the ending times that are given in your flowers array, you will be separating them in two vectors, and your vectors will be, I think C++ allows this type of declaration, uh, bloom start time and bloom end time. These two vectors, and bloom start time will be containing the first value, uh, bloom start time dot pushback. We will push back the time 0th index. Similarly, start time, bloom end time will be having the second entry in the times array. It will be time, not time. So similarly here also times second entry. Okay, that part we are done with. So we also forgot to sort these times. So bloom start time dot begin and bloom start time. This is just a C++ syntax. Those of you who are watching and prefer some other language, let's say Java or Python, the code will also be available in those languages. Okay, and yeah, and similarly we will do for bloom end time. Begin and bloom end time dot end. Yeah, so these two numbers will be calculated. Here it will be arrival time. Okay, and let's define the function and implement it. Let's declare this function private, void find bloom number. Here it will be your times array, let's say. Here it will be your arrival time. Okay. So the values of arrivals, as you can see here, is well within the range of integer. So we need not have to worry about that, I think. So anyhow, we will be, what will be our search space? Search space will be from left to right. Left will be the 0th index and your right will be the size minus 1th index, and your size will be the size of the times array. Dot size. Okay. It will be size minus 1. And this is just a binary, standard binary search. Those of you who are not familiar with binary search, I will be providing, also be providing the link of article describing binary search. Basically, this binary search will run in order of log n time, where n is the length of times array. Okay. Maximum length of times array that can be possible, or that is given, let's say. Okay, then left is less than equal to right. Till this condition is satisfied, we will do some work. We will find the mid index, which will be left plus right minus left whole divided by 2. So this is essentially nothing but, if you simplify it, right plus left whole divided by 2. We are performing this to prevent integer overflow, so that our result can be stored in a integer value. Okay, then let's say if the value at times array at mid index that you have just calculated is what was the constant before or at the arrival. Okay, before or at the arrival, so lesser than or equal to your arrival time. Then what you will do, you will, let's say, declare another variable. Bloom count, or say flower count. Not flower count exactly. Answer index will be a correct term. Okay. Initially you will represent it by, let's say, -1. Or if not -1, let's call it the size of the array. So this is how you will be updating your answer index, because number of flowers blooming for n to bloom after this particular time, the index of flowers blooming, leftmost index, you have to find out leftmost index of flowers. Basically, in C++, instead of implementing this binary search, we can implement We can use two inbuilt functions. Those will be similar to binary search. Let's use them. So if you see this particular value, this value, let's say I do something like this, full bloom start number plus 1 will be a separate term, and then full bloom and a number. It will save some implementation time, though I don't think so that in Java and Python I remember such a function that exists in them. There I will provide the implementation for this particular part. You can have something like this. So it will be nothing but the upper bound of arrival time, upper bound of arrival time in which array? Start points. And this particular value will be lower bound of arrival time. Let's call this 80 in endpoints. Okay. So these two functions can are essentially binary search implementations. Those of you who are not familiar with these two functions and are using C++, uh, I will be providing a link of these two functions, lower bound and upper bound. Okay, this particular article you can explore, then you will be able to see what the lower bound is and what the upper bound is. Okay, now instead of this implementation in C++, now let's use those inbuilt functions to save some implementation time and shorten this video length. So what we will find upper bound of it will be upper bound bloom start time dot begin. This is just a syntax, bloom start time dot end. Okay, and arrival time. Similarly here, bloom end time dot begin, bloom end time dot end, and this will be lower bound. This particular one will be representing values greater than index of values. If you want to find out the index, let's say, then you will do bloom start time dot begin. Here also you will subtract bloom end time dot begin. Index of array of time in bloom start time array, which is greater than, which is having value greater than current arrival time. Okay, and similarly this one will return you index of time in bloom end time array, which is having value at least equal to more equal to current arrival time. Basically, the first value that is satisfying this particular constraint will be returned here and here also. Okay, it's mentioned here that the iterator pointing to the first element in the range which has a value not less than value. So the value which iterator of the element which is not having a value lesser than the given value will be returned in case of lower bound, and in case of upper bound it will be the first element which is having value greater than the value mentioned. So index of the first time value. Similarly here also index of first time value. Okay, I hope you are able to understand. These two are nothing but binary search implementations, and then you will be storing your answer of the, let's say, ith index will be your start time bloom start number, since it will be greater, minus your bloom end number. At last you will return your answers array. I think this should be it, and the problem is solved. I think it will be answers instead of answer. Okay, if you are confused with these two terms, then this is what we have applied here. Full bloom start number plus 1 minus full bloom end number. Okay, so let's try to submit for the sample test cases, see whether we are getting it accepted or not. So some error is being thrown. Bloom start time, typing mistakes. Again, the same mistake is there. Okay, bloom start number and bloom end number. We have, I think, again done some typing mistake. Bloom, okay. bloom start number and bloom end number it should be. Let's try to submit again. Yeah, as you can see, for sample test cases we are getting correct results. Now let's try to submit for the final evaluation. Let's see. Yeah, as you can see, it's getting accepted. Okay, and if you are still having any doubts and you are not familiar with binary search, then binary search binary search article will also be given to you. This article link I will provide. So here it will explain, I think, why this low plus high minus low by 2 I was taking. Rest all is fine. And yeah, instead of those single function that I was implementing, I think that function will work. But we have used upper bound. We have uh, combined this plus one with the bloom start number itself. So that's pretty much it from my side. If you are still having any doubts, please feel free to ask them in the comment section. So I will be more than happy to answer them. Thank you for watching. Thanks.